Algebra is the mechanical engine that powers the entirety of A-level mathematics. While your AS-level studies introduced you to quadratics and basic coordinate geometry, this Pure 3 unit elevates your skills to handle much more complex, non-linear, and rational functions. You are transitioning from solving self-contained puzzles to building the exact algebraic toolkit required for advanced calculus, differential equations, and numerical approximations. In this unit, we will dismantle and reconstruct mathematical expressions, ensuring you are never intimidated by the shape or size of a function again. We are going to break down heavy polynomials, split fractions apart, and stretch expressions out into infinite series.
We begin with the modulus function. This is your mathematical tool for handling absolute magnitude, stripping away negative signs to model strict distance. You will learn to sketch its sharp, reflective V-shaped graphs and solve complex equations and inequalities where variables are trapped inside absolute values. Crucially, Cambridge examiners want to see you identify and discard the extraneous roots that artificially appear when we square both sides to solve these equations. Always check your answers by substituting them back into the original equation.
Next, we tackle heavy, high-degree polynomials. You will master algebraic long division to simplify fractions where the numerator has a higher or equal degree to the denominator. But when you only need to find a root or a remainder, long division is simply too slow. That is where the factor and remainder theorems come in. These powerful theorems allow you to rapidly prove whether a linear expression is a factor, or deduce unknown coefficients hidden within the polynomial. You will often set up simultaneous equations to unlock these 4 to 6 mark logic puzzles in the exam. Remember, magic calculator answers score 0 here. You must show the algebraic working.
Once you can divide polynomials, you can reverse engineer algebraic fractions. In the partial fractions topic, you will learn how to shatter a complex, combined rational expression into simpler, bite-sized pieces. Whether the denominator contains distinct linear factors, repeated linear roots, or irreducible quadratics, this decomposition process is absolutely essential. It is the mandatory first step before you can integrate a complex fraction or expand it into a series. Examiners love testing this as the opening to a massive 10-mark synoptic question. You cannot integrate a complex algebraic fraction directly, so partial fractions are the key that unlocks the rest of the problem.
Finally, we stretch these expressions out into infinite series. You already know the binomial expansion for positive integers, but now you will approximate functions raised to negative or fractional powers. Because these new series are infinite, they only converge under strict mathematical conditions. Stating the exact domain of validity, where the magnitude of x is strictly less than 1, is a critical standalone accuracy mark in Paper 3. You will use this to approximate complex roots and fractions with incredible precision. If a question asks for an expansion, ensure your partial fractions are simplified and ready for this exact formula.
This unit forms the bedrock of Paper 3. The topics form a sequential pipeline. You cannot expand a complex rational function without first decomposing it into partial fractions, and you cannot decompose it without understanding polynomial division. Master these mechanics until they are automatic. Respect the domain of validity, and always check for extraneous roots. Get this right, and the rest of the pure syllabus will fall effortlessly into place. You are now ready to begin.